Right. Next topic is gamma distribution. So, what is gamma distribution? A continuous random variable x in the limits 0 comma infinity 0 comma infinity has the probability density function f of x is equals to 1 by gamma of lambda into e to the power of minus x into x to the power of lambda minus 1. F of x equal to 1 by gamma of lambda into e to the power of minus x into x to the power of lambda minus 1, where x is greater than or equal to 0 and lambda greater than 0 is called gamma distribution with the parameter lambda. Here. Now it is denoted by x follows gamma of lambda. So this is the PDF of gamma distribution. Okay. Now let's find out the gamma integral. So the gamma integral is, so generally we should use the property of continuous random variable integration f of x dx is equals to 1, right? So integration of what is f of x? 1 by gamma of lambda into e to the power of minus x into x to the power of lambda minus 1 dx is equals to 1, where the limits are 0 to infinity by the definition, right? So this gamma of lambda going that side, so e to the power of minus x into x to the power of lambda minus 1 dx is equals to gamma of lambda. So this is the gamma integral where we can use in the moments and the properties, right? So this gamma distribution is with one parameter. This is the definition for gamma distribution of one parameter, right? Only one parameter is there. So in another definition we have two parameters. Though what is that? A continuous random variable x in the limits 0 to 0 comma infinity has the probability density function f of x is equals to e to the power of lambda by gamma of lambda into e to the power of minus ax into x to the power of lambda minus 1, where x greater than or equal to 0 and a greater than 0, lambda is also greater than 0. So this is the definition of gamma distribution with two parameters. What is the parameters here? Parameters are a comma lambda are parameters here. Okay, so this is the definition of gamma distribution with two parameters. Now next we need to find moments. So first, non-central moments. So first we need to find rth moment in your dash, that is equals to expectation of x power r, that is equals to integration of x power r into f of x dx, right? So integration of x power r into f of x. What is f of x? 1 by gamma of lambda into e to the power of minus x into x to the power of lambda minus 1 dx, where the limits are 0 to infinity, right? So now integration of x to the power of r into 1 by gamma of lambda e to the power of minus x into x to the power of lambda minus 1 dx, 0 to infinity limits, right? So now 1 by gamma of lambda is a constant, so take it outside. 1 by gamma of lambda integration of e to the power of minus x into x to the power of, here bases are same, x to the power of r is there, x to the power of lambda minus 1 is there, so add it, lambda plus r minus 1, lambda plus r minus 1 dx, right? So now it is look like the gamma integral function, integration of 0 to infinity e to the power of minus x into x to the power of lambda plus r minus 1 dx is equals to gamma of lambda plus r. So why? So here in place of x to the power of lambda we are having lambda plus r minus 1. So in place of lambda we are having lambda plus r. So you can get gamma of lambda plus r using gamma integral, using gamma integral. Okay, so earth moment, what is earth moment? Gamma of lambda plus r by gamma of lambda, right? So now simply substitute r is equals to 1, so we get mu 1 dash gamma of lambda plus 1 by gamma of lambda. So gamma of lambda plus 1 can be written as lambda plus 1 minus 1 of gamma of lambda plus 1 minus 1 divided by gamma of lambda. So lambda plus 1 minus 1 means these both are gets cancelled, so remaining lambda into gamma of lambda by gamma of lambda. So gamma of lambda gets cancelled, remaining lambda, that is mu 1 dash r mean. So next simply substitute r is equals to 2, we find mu 2 dash, so that is gamma of lambda plus 2 by gamma of lambda, that is equals to lambda plus 2 minus 1 gamma of lambda plus 2 minus 1 by gamma of lambda. So here 2 minus 1 means lambda plus 1 into gamma of lambda plus 1, remaining lambda plus 1 into gamma of lambda plus 1 by gamma of lambda, that is equals to lambda plus 1 of again gamma plus 1, sorry, again gamma of lambda plus 1 means you can write lambda plus 1 minus 1 of gamma of lambda plus 1 minus 1 divided by gamma of lambda. So plus 1 plus 1 minus 1 gets cancelled, so remaining lambda plus 1 of, here remaining lambda into here remaining gamma of lambda divided by gamma of lambda. So gamma of lambda gets cancelled, remaining lambda of lambda plus 1. So this is mu 2 dash. Okay, so again now substitute r is equal to 3, we can find mu 3 dash. So gamma of lambda plus 3 divided by gamma of lambda, that is equals to gamma of lambda plus 3 means again lambda plus 3 minus 1 gamma of lambda plus 3 minus 1 divided by gamma of lambda. So here remaining lambda plus 2 of gamma of lambda plus 2 by gamma of lambda, that is equals to lambda plus 2 of again gamma of lambda plus 2 means lambda plus 2 minus 1 gamma of lambda plus 2 minus 1 divided by gamma of lambda. So lambda plus 2 minus 1, lambda plus 2 minus 1 means lambda plus 1 gamma of lambda plus 1, right? So that is equals to gamma of, sorry, here remaining lambda plus 2 of lambda plus 1 of gamma of lambda plus 1 divided by gamma of lambda. So again gamma of lambda plus 1, you can find that lambda plus 2 lambda plus 1 into lambda plus 1 minus 1 of gamma of lambda plus 1 minus 1 divided by gamma of lambda. So plus 1 minus 1 gets cancelled, remaining lambda plus 2 into lambda plus 1 into lambda of gamma of lambda by gamma of lambda. So gamma of lambda gets cancelled. So the remaining is lambda into lambda plus 1 into lambda plus 2. This is mu 3 dash. So now substitute r is equals to 4. So mu 4 dash we will get, that is gamma of lambda plus 4 by gamma of lambda. So what should we here get? I can write it directly here using third central moment. So lambda into lambda plus 1 lambda plus 2. So here we can get, by solving this equation, we should get lambda of lambda plus 1 lambda plus 2 into lambda plus 3. So this is mu 4 dash. So the next topic is central moments. We need to find the central moments. So mu 2. So mu 2 is equals to variance, that is equal to, what is the formula? Mu 2 dash minus mu 1 dash whole square. So what is mu 2 dash? We are getting mu 2 dash is lambda into lambda plus 1, right? So minus mu 1 dash is lambda whole square. So lambda square plus lambda minus lambda square. So lambda square gets cancelled, remaining lambda. So variance of gamma distribution is lambda. Okay. So mu 3, third central moment. So third central moment is, when you substitute third central moment, mu 3 dash minus 2 into mu 2 dash mu 1 dash plus 2 into mu 1 dash whole cube. When you substitute in that formula, you will get 2 lambda. I am writing here directly, you can do it on your own. And mu 4, the fourth central moment is, you are getting 3 lambda of lambda plus 2. 3 lambda of lambda plus 2 or 3 lambda square plus 6 lambda. You are getting mu 3 and mu 4. So next, skewness of gamma distribution. So skewness is denoted by beta 1, mu 3 square by mu 2 cube is the formula. Mu 3 square by mu 2 cube is the formula. What is mu 3? 2 lambda square plus, what is mu 2? Lambda whole cube, right? So here 4 lambda square by lambda cube, that means 4 by lambda. You will get 4 by lambda, it is greater than 0. And the gamma 1 is equal to square root of beta 1, right? So square root of beta 1 means 4 by lambda, that is equal to 2 by square root of lambda, right? So therefore the gamma distribution is positively skewed. Positively skewed, right? So next topic is kurtosis. What is kurtosis formula? Beta 2 is equals to mu 4 by mu 2 square. What is mu 4? 3 lambda square plus 6 lambda by mu 2. Mu 2 is lambda square. Mu 2 square means lambda square, right? So when you take out separately, 3 lambda square plus lambda square plus 6 lambda by lambda square. So lambda square, lambda gets cancelled. So here the remaining is 3 plus 6 by lambda. 3 plus 6 by lambda. So when you take out this, you will get, when you take out common, 3 1 plus 2 by lambda, which is greater than 3 only, right? So which is greater than 3. Since beta 2 is greater than 3, so gamma 2 we need to find beta 2 minus 3, right? So what is beta 2? Beta 2 is 3 plus 6 lambda minus 3. So 3 gets cancelled. 6 by lambda you will get. 6 by lambda you will get, right? So therefore gamma distribution is leptokurtic distribution or. So next is we need to find MGF of gamma distribution. So what is the symbol of MGF? Mx of t, that is equals to expectation of e to the power of tx, right? So expectation of e to the power means e to the power of tx into f of x dx, that is equals to e to the power of tx. What is f of x? 1 by gamma of lambda into e to the power of minus x to the power of lambda minus 1 dx. So where limits are 0 to infinity, so here constant value is 1 by gamma of lambda written as outside into, so integration of e to the power of dx into e to the power of minus x to the power of lambda minus 1 dx. So that is equals to 1 by gamma of lambda integration of e to the power of dx minus x, so these are same, x to the power of lambda minus 1 dx where 0 to infinity limits. So 1 by gamma of lambda integration of e to the power of, the common term is here x to the power of lambda minus 1 dx, right? So 1 by gamma of lambda integration of e to the power of, here taken again minus common, so when it common minus, here become minus t plus 1, right? So minus t plus 1 means 1 minus t we can written, right? 1 minus t of x into x to the power of lambda minus 1 dx, where the limits are 0 to infinity. So it is look like again gamma integral with two parameters. What is gamma integral? Two parameters. Integration of 0 to infinity e to the power of minus ax into x to the power of lambda minus 1 dx is equals to gamma of lambda by a to the power of lambda. So this is gamma integral with two parameters, right? So now compare here, e to the power of minus ax means e to the power of minus 1 minus t. A means 1 minus t of x into x to the power of lambda minus 1, x to the power of lambda minus 1, right? So now what will it become? Gamma of lambda means in place of lambda we are having only lambda, but in place of this one a is equals to 1 minus t, right? So 1 by gamma of lambda into this whole term become gamma of lambda by a to the power of lambda. A means 1 minus t whole to the power of lambda, right? So gamma of lambda gets cancelled, so here remaining 1 by 1 minus t whole to the power of lambda. So when we come numerator 1 minus t whole to the power of minus lambda. This is mx of t of gamma distribution with one parameter. So similarly, the characteristic function CHF is pi x of t is equals to 1 minus it whole to the power of minus lambda. 1 minus it whole to the power of minus lambda. So the same remaining process will be same. Instead of expectation of e to the power of tx, we need to substitute e to the power of itx. In place of t, we need to substitute all it. So we can get characteristic function. Okay. So next, CGF of gamma distribution. So CGF symbol is kx of t, that is equals to log mx of t. Log mx of t. So log of what is mx of t? So far we can get 1 minus t whole to the power of minus lambda, right? So log x to the power of n means n into log x, log of 1 minus t. So here log 1 minus x formula. So what is log 1 minus x formula? X plus x square x minus x square by 2 minus x cube by 3 minus x power 4 by 4, so on, right? So in place of x here we are having t. So minus lambda of t minus t square by 2 minus t cube by 4 and so on. So minus will be going that side, lambda of t plus t square by 2 factorial, 2 plus t cube by 4, 3, here 3 plus so on. Okay, so this is the expansion of log 1 minus x, right? So using this equation we need to compare and we can get cumulants and moments. Cumulants and moments. So what is k1? K1 nothing but mu1 dash or mean, that is equals to lambda. K2 is nothing but variance, that is nothing but also lambda. Coefficient of t in kx of t equals to lambda. Coefficient of t square by 2 factorial in kx of t, that is equals to lambda. And k3 is also known as mu3, that is equals to 2 lambda. And k4, so k4 is 6 lambda. Coefficient of t in t power 4 by 4 factorial is 6 lambda. Mu4 is equals to k4 plus 3 into k2 square. Plus 3 into, what is k4? 6 lambda plus 3 into k2 square means lambda square. So 3 lambda square plus 6 lambda is fourth central moment. So this is the properties of gamma distribution with one parameter. So similarly, you can do gamma distribution with two parameters. Gamma distribution with two parameters, that is a comma lambda. So PDF is f of x is equals to e to the power of lambda by gamma of lambda into e to the power of minus ax x to the power of lambda minus 1, right? So you can do all the moments central and non-central, and such as properties MGF, CHF, CGF. You need to find.